Now let's dive into something a little more advanced in terms of creating basically, looking at the differences. We left off with this data frame. We had combined the two data sets from the baseline versus the schedules change scenario. We can see there's a difference here. And we want to create a new column in our data frame to quantify that difference. And this is common in spreadsheets, of course. You would create what's called a calculated column. Data frames have a very similar functionality where you basically just call the name of the data frame, you make up a new name here, put it in parentheses, and basically take the two other columns. And this time we're going to subtract the scenario from the baseline. And what we end up with is a new column called difference. So this difference column, of course, is the subtracting the scenario from the baseline to see how much energy is actually saved through that scenario. And of course, we can also visualize this difference this time using a bar chart. So we can use the notation .bar, which allows us to create a visualization. And we're only applying that visualization to the difference column. And we're changing the title. So it's, of course, difference between baseline and improved schedules and total gigawatt hours. So you can see that this bar chart is really the maximum difference here, which we saw in the line charts also is in the hottest summer months. We can also create new columns by defining a function object to create a new column. So let's say we only care about comparing all months except July. But what we can do is create a function. So we define a function called getDifference. If monthly data.name is equal to July, we return 0. Else we just return basically the difference between the baseline and the scenario itself. We're going to create another column called difference no July. We're going to use the .apply function. And lambda x means that for every row in this data frame, it's going to send that row to get difference conditional. It's going to basically send that row to this function for each of the rows. We're telling .apply to apply it to each row, not each column. So axis equals 1 means we're applying it to basically the index. And when we run this, we can take a look at the new visualization here of our new column called difference underscore no July. And we can see here that July is missing. It's 0, actually. So you can do really complex calculations on columns, similar to what you can do in a spreadsheet. And of course, in spreadsheets, you can have very complex notation. But here, of course, you could put any number of lines of code in this function. So you can really do more advanced transformations in I think, an easier way. So we have other scenarios besides just the schedule scenario. Here we have a scenario called glazings, which is basically to improve the glass or windows in the building. So we want to use what's called low E glass, which reflects more of the heat gain than regular glass. We want to look at a scenario called cool painting on roof. So we want to apply white coatings to the roof to basically reflect more of the heat energy to reduce the solar absorptivity of the roof to reduce cooling load. We may look at changing the set point when temperature set point is reduced. So we actually are making it cooler inside the building. That has the potential to actually probably raise energy consumption. And then rooftop gardens. So actually planting lots of vegetation on a roof can also reduce the solar heat gain of the building in a hot climate. If you remember, we have all of these files over here in the data set, baseline versus all 5 of these scenarios. What we need to do is we want to load each of the data from each of these files. So what we'll do first is go ahead and create a list of all the file names that we want to load. And let's take a look at what that looks like. Obviously, it's quite simple. It's a list. And we're going to use a for loop, of course, for the file name in list of files. In this very simple version, we're just going to print the file name. So what we want to do instead of just printing them is we're going to create a chunk of code which is going to go through each of the files. And we'll create a very simple container file called data container, which is empty to begin with. We'll go through each of the files in this file list, print the file name. We'll read the .csv from that file. Here we have general file path, and then we're adding the file name. So we're merging together these two strings to create the entire file path. We're making the index column month, we're appending that data frame to a list. At the end, we're going to use concat to glue all of those lists, all of the data frames in that list together. So we do that, we can see that it cycles through this. What we see as an output here is a result of printing that file name each time. And what we'll see when we look at the data frame is we have our list of 12 months. We have a whole bunch of columns here. A good way to look at this, of course, is .info. .info gives us a kind of a list of the column names. So it gives us a high level overview. We notice that we have 12 entries in the index still. We have 12 non-null values for each of the columns. So there is no missing data, which is great. And of course we can plot this. So we'll plot this using a line chart. We can see the difference. We added line weights, different color maps. Color map, just so you know, is the template of a color scheme. There's a whole bunch of different color maps out there, which we'll learn in future episodes. And here you can see the differences between them. The baseline, of course, is the highest consumer. And you can see the differences between some of the others with cool roof and low E glass and these things. So the last part of this video is going to tease on something called Stack Overflow, or basically finding support online, essentially. Let's say we want to look at the differences between some of these scenarios. So we want to subtract all columns in a data frame from one column. And so what I do, and I still do this, I've been coding now for over 10 years. And what I still do sometimes is if I don't know how to make the code for it, I basically just Google it. I use the best coding assistant in history called Google. And what I end up with when I Google this is a website called Stack Overflow. And this is one of the answers, subtracting many columns in a data frame by one column. So we'll talk about this in more detail about Stack Overflow and how beautiful this is and how much it helps you. But basically in this situation, I'm using Stack Overflow to get some understanding of how to do this. And I'm using that to show, basically to subtract each of the different columns from the baseline. So of course, and we can see basically which of the columns does the most impact has the most impact. And scenario increase set point. Sorry, before I mentioned, I was thinking increase set point. I was thinking heating for some reason. Heating would actually increase the energy consumption, but increasing the set point in a hot climate is actually going to decrease energy significantly, which you can see here is this scenario is by far the biggest energy saver. You can also troubleshoot using Stack Overflow. So once again, I'll talk about this in the future, Stack Overflow being your best friend. Here's an example of we want to drop one of the columns. We're using a function called .drop, but we're not filling out all the necessary attributes for this. And when we do that, we get this big red area on Kaggle notebooks. So don't let these things scare you. This is a value error. It says you need to specify at least one of these different attributes. If we actually do that, we can see that it works. So here we want to drop the column called baseline. You can see the resultant data frame has no baseline column. So if you've done exercises, you're going to run into errors. That's okay. That's all part of the process. You have to debug those errors, and Stack Overflow is your best friend. So thank you for paying attention, and see you in the next video.